Assalamu alaikum wa rahmatullahi wa barakatuh. How are you guys? How are you girls? Welcome to Manhal Schools for American Diploma. Today, inshallah, you will study a new lesson in math, which is chords and arcs in geometry. Chords and arcs. Okay. First, you must know we have more theorems in this lesson, but it's easy, inshallah, it will be easy. Theorem 1, within circle or incongruent circles, congruent central angles have congruent arcs. Congruent central angles have congruent arcs. So in this figure, we can say if measure angle DOC equal measure angle AOB, so we can say arc DC congruent to arc AB. This in the same circle or incongruent circles. Okay. So if measure angle AOB equal measure angle DOC, then arc AB congruent to arc CD, not like this. Not just this, but the converse is true else. So if the arc AB congruent to the arc DC, so the angle measure angle AOB equal measure angle DOC. Theorem 1. What about theorem 2? In theorem 2, we can say within circle or incongruent circles, congruent central angles have congruent chords. So we can say if measure angle AOB equal measure angle DOC, so the chord AB congruent to the chord CD. And the converse is true. Okay, if the chord AB congruent to the chord CD, so measure angle AOB equal measure angle DOC. Is theorem number 2. Theorem number 3. Within a circle or incongruent circles, congruent chords have congruent arcs. So if the chord AB equal chord DC, so the arc AB congruent to the arc CD. So finally we can say if you have congruent central angles, so the chords are equal and their chords are equal and their arcs are equal. And if you have two chords are equal, then their central angles are equal and their arcs are equal. Okay. Theorem 4. Within a circle or incongruent circles, chords equidistant from the center of the circle are congruent. Are what? Congruent. That means what? If you have two chords like AB and CD, like AB and CD, and they are equidistant. Equidistant means what? Means at equal distance from the center. At equal distances from the center. Okay, that means OE equal OF. Again, if OA perpendicular to OB and OF perpendicular to CD, so they are distances. If they are equal, if the distance are equal, so the chords are equal. So if the chords equidistant from the center at equal distances from the center, so the chords are congruent and the converse is true. Okay, this theorem number 4. But theorem 5, 6, and 7, 5, 6, and 7, okay, according to the same idea. Okay, what's the idea of these theorems, these three theorems? If you have a circle like this, and you have a chord like this, for example, and okay, the center here is M. Okay, so the line drawn from the center will, okay, perpendicular to a chord, then bisect it. Okay, then bisect it. If the line passing through center and perpendicular to a chord, then bisect it. And if the line passing through center and bisect the chord, then will perpendicular to it. And the line which is perpendicular and bisector of a chord contains the center of the circle. So I have three theorems like each other. In a circle, if a diameter is perpendicular to a chord, so then then it bisect the chord and its arc. Bisect the chord and its arc. So BA, BA. If BA here is yes, diameter and perpendicular to the chord CD, so it will be bisect the chord and bisect the arc. Theorem 6. In a circle, if the diameter, this diameter bisect the chord, then perpendicular to the chord, then it will be perpendicular to the chord. And the perpendicular bisector of a chord contains the center of the circle. Okay, so if AB is a perpendicular bisector of the chord CD, so it will pass through the center of this circle, pass through center of this circle. For example, in this figure, ED equals what? Okay. Here, what do you notice that? You notice that measure angle EMD equal measure angle DMC. So we have two congruent central angles. If you have two congruent central angles, so the opposite chords are equal and the opposite arcs are equal. So we can say ED equals, yes, good, DC. Chord ED equal chord DC. And arc DC, yes, this arc DC, congruent to what? Yes, congruent to arc ED. Arc ED, because they have two congruent central angles. Okay, number 3, AB equals what? Okay, we notice that AB and EF, these chords, equidistant from the center. Equidistant from the center M. Yes, if AB and FE are equidistant from the center M, because MN equal MO, so the two chords AB and EF are equal. So we can say AB equal EF. Number 4. We noted that, guys, that MN and MO are two perpendicular lines from the center to a chord. From center to a chord, then bisect the chord. Then bisect the chord. So we can say OF, this one, equal, yes, OE. Equal OE. Okay, good. Number 5. If AB equal 8, yes, AB equal 8. Sure, if AB equal 8, so N will be midpoint of AB. So it will be 4 and 4. Okay. And OM equal 3. OM here is 3. So MN else equals what? 3. Then the radius equals what? What's the radius? The radius is the distance between center of the circle and any point on the circle. Radius is the distance of the circle and any point on the circle. Okay, so I can draw from M to A, for example. This what? This radius. Okay, and this equal 3. And this one half of 8, which is 4. And this triangle is right angled triangle. So we can find radius using, yes, Pythagoras theorem. Radius here in this triangle like hypotenuse. So I can find the hypotenuse by square root of 3 power 2 plus 4 power 2. It will be 5. It will be 5. Okay. Next exercise. In circle O, measure arc CD equal 50. Okay. And CA congruent to BD. This chord congruent to this chord. Number 1. What's measure arc AB? Yes, it's easy. Okay, we know that measure angle COD equal measure angle AOB, but why? Because they are vertically opposite angles. So you have two central angles which are congruent, so the opposite arcs are congruent. So measure arc AB equals 50. Equal 50. Okay, this number 1. Number 2. What's true of CA, arc CA, this one, and arc BD? What's the relation between them? They are, yes, congruent. So we can say arc CA congruent to arc BD. Number 3. Since CA equal BD, what do you know about the distance between CA and BD from the center of O? Okay, you have two equal chords. If you have two equal chords, so they are equidistant from the center. Okay, so we can say since CA or AC equal BD, two chords are equal, so then they are equidistant. They are equidistant from the center of the circle O. So they are equidistant. So what about distance of CA and BD from the center? They are equal because the distances are equal because the two chords are equal. Thank you for listening and meet you after, inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.